what's up? Nasir Malik here. Today we'll be looking at the programming an ESP8266 board. We will set up and flash ESP8266 ESP01 board using FTDI TTL programmer. We will set it up on our network so Alexa can discover it, and we'll be able to control it with our voice commands. Let's get started. You will need the following components for this project: Amazon Echo Dot or Echo, FTDI USB to TTL board, ESP8266 ESP01 board, and the mini USB cable, and of course you will need a computer to program it. So here are the highlights. Install Arduino IDE for programming and uploading firmware. Install ESP8266 required libraries to Arduino IDE. Connect FTDI and ESP8266 on breadboard. Flash a simple LED blink program and upload it to ESP8266. Flash the ESP board with IOT program so Alexa can discover and control the onboard LED. You will need to go to the following URL. I will include this link below the video, and you will look for download Arduino IDE. I will download the Windows version. You can download the appropriate version for yourself. And I will click on just download button, and Windows save file dialog will appear. I will save this to a local drive on my computer. And click the save button. Once it finished downloading, you can install it. Since I already have it installed, let me open up the program. So once you're in the program, the very first thing you need to do is go to File, Preferences, and type in this URL. Save it. Go to Tools menu, Board, Board Manager, and type in ESP8266. And install this package. Select it and click Install. Let's wait for it to complete installing. In this project, we will be using following components: Amazon Echo Dot, ESP8266 ESP01 version board, FTDI USB to TTL board to flash ESP8266, a mini USB cable, a breadboard, and some wires. Let's look at the pinouts for each board. Let's start with FTDI board. First pin is ground. You skip the second pin. Third pin is 3.3 volts. Fourth pin is TX, and fifth is RX. In this project, we will not be using the last pin and the second pin. Let's look at the ESP8266 pinout. So there are two rows of pin. We're going to start from the bottom one. The first pin is VCC 3.3 volts. Second pin is reset pin. Third pin is CHPD pin. The first pin and the third pin requires 3.3 volts to operate. And then the fourth pin at the end is TX communication pin. On the top row, the first pin is RX communication pin. Second pin is GPIO 0. And the third one is GPIO 2. And the last pin is ground. Let's hook up the wires to this board. I have these female to male connector pins for breadboard. I will use the blue and the red pin for the 3.3 volt. and a gray wire for the ground, and a white one for GPIO 2 pin. So if you look at the board, the bottom row, the very first pin is VCC 3.3 volt. So we need to provide 3.3 volts to first pin and the third pin from the bottom. So I will connect red to the first pin on the bottom and blue one pin. So these two pins require 3.3 volt to operate this board. The black one will go into the ground, which is the last pin on the top row. And the white pin will go to GPIO 2, which is right next to the ground pin. Okay. So this is done. We're going to install the FTDI board to the breadboard. Next, we're going to connect the ESP8266 to the breadboard using these wires. So as you know, the blue and the red requires 3.3 volts. So if you look at the board, the first connector is ground, the third one is 3.3 volts. I will install the two wires that require 3.3 volts to this pin, third pin. So these two wires are connected on the same row on a breadboard on the third connector on the FTDI board. Next, I will install the ground wire to the ground on a breadboard for the and the GPIO 2 we will connect on a separate line. That is it for this. Now let's hook up the communication wires to the ESP8266. I will be using these two wires, female to male connectors for the breadboard. So if you remember, the last pin on the ESP8266 is a TX pin. So we'll connect this to TX. So now on the breadboard, it needs to be connected to FTDI connector on a RX. So remember, you will not connect TX to TX or RX to RX. It needs to flip. So from ESP, it needs to go from TX to RX and RX to TX. So this wire is connected to TX on the ESP8266. We will connect this to RX pin on the breadboard. If you look at the FTDI board, from the left, the second pin is RX and the third one is TX. So we will connect this TX to RX. So we'll connect this to RX. Now next, we'll connect this wire to RX on the ESP8266. The very first pin on the top row is RX. We'll connect this yellow wire to RX. As you can see this. And on the breadboard, it will be connected to the TX pin, which is this one, third pin from the left, this right here. So we're going to install this. Like that. We just finished connecting the wires between the USB to TTL programming board and ESP8266 chip. ESP8266 board. So now we're going to connect this to the PC and flash this board and upload a program that will turn on and off the onboard LED light periodically. To flash ESP8266, you need to connect GPIO 0 to ground. So we're going to connect this black wire to GPIO 0 and we're going to ground it. So on the board, on the top row, the second wire is GPIO 0. We'll connect this to the ground. We'll connect this on the board to the ground. As you can see, this is connected to the ground. So now to put this into a flashing mode, you need to have this wire connected to the ground before you power up. So now I'm going to connect it to the computer. I'm going to go ahead and flash a simple program to the chip that will blink the onboard LED on and off periodically. Before you can flash your ESP board, you need to make sure it is connected to your computer, and you have to select a few settings in Arduino IDE. Go into Tools, Board. Here are all available boards that you can program. So we need to go down and select generic ESP8266 module. This is the module that I'm using. If you're using a different module, you have to select an appropriate board. I will select generic ESP8266 module. Once you select that, you go back to Tools and make sure your upload speed is set to 1150-200. And then you go back to Tools, Port, and you make sure you have a correct port selected. Mine is COM6. Yours could be different, so whatever port is enabled, you select. If you have multiple ports, make sure you have the correct one. And now you're ready to flash your ESP board. So I can access the program going to the File menu, Examples, and go to the ESP8266 blink. And this will open up a simple program. So while the chip is connected and it's in the flashing mode, I can go ahead, compile and upload this program by clicking this button. It's compiling a program right now. And as you can see, it's flickering the blue LED while it's uploading the program. It just completed. Now if we restart it, it should blink the LED on and off periodically. I'm going to unplug it and plug it back in. As you can see, it blinks the blue LED on and off. So let's flash ESP8266 board with firmware that will connect to our network and we'll be able to receive commands from Alexa or controlled by Alexa. So first, let's put the GPIO 0 pin to ground before we turn it on. So we'll ground the GPIO 0 pin so we can boot it in a flash mode, so we can flash the ESP8266 again with the new firmware. So I'm going to connect it. And you can see the light coming on. So now we're going to remove the GPIO 0 ground pin. Now I'm going to copy the new firmware code. I will include the link below the video. So in this framework, you don't need to change anything. You only need to provide SSID for your Wi-Fi router and a password and the name you want to give it to this device on the network. This is important because Alexa will recognize this ID with this name. So I'm going to put in my network credentials and the name I want to give it to this device. The name I'm going to give to this device is demo switch. And now I'm going to compile and flash this firmware to ESP8266. You should see the LED blinking on the board. I'm going to click and compile. It is compiling right now. So it finished compiling and now it is uploading the firmware to the ESP board. As you can see, the USB to TTL board is flashing, and also you can see the ESP onboard blue LED is flashing. That means it's uploading the firmware. The new firmware install is completed. Now I'm going to reset it by unplugging and plugging back in. Now I'm going to ask Alexa to discover devices on the network. Alexa, discover devices.
Starting discovery. This can take up to 20 seconds. If you have Phillips hue, press the button on your bridge. Discovery is complete. I found one smart home device. If your Philips bulbs were not discovered, please press the button on the bridge and rerun discovery.
So now I'm going to control onboard LED through Alexa. So Alexa already discovered this device. The device name is demo switch. So I'm going to ask Alexa to turn it on and off, and you should see this light LED going on and off. Alexa, turn on demo switch.
Okay.
Alexa, turn off demo switch.
Okay.
So as you can see, it is very easy to upload a firmware, flash this ESP8266 chip, and do different things. So for this tutorial, this is it. For the next tutorial, we'll hook up a relay with it and control other electronics. Until next time, bye bye.